Hey guys, sorry it's been a while since my last upload. So today we will be doing, this is another chemistry video requested by Jeffrey. We'll be drawing loose dot structures for these different compounds. So if you're in Mr. Benson's class, I wanted to offer you guys a new method to solve these problems, which he did not teach us, but it seems to work pretty well in every case. So we'll start with A. We have N2H2. H2. So we start by placing the different atoms. H's are always on the ends because they only have one single bond. So that means the ends are in the middle. So now that we have these, the trick is to first count up how many electrons do the atoms want. So what this means is we add all the valence electrons each atom needs. So for H, for example, we'd have 2, and for N, we'd have 8. So anything other than H pretty much is 8, and then H is 2. So we have 2 H's, so that's 4. Then we have 2 N's, which is 16. So 16 plus 4 is 20. We can write that down. This is the want. And then we also need to find the has. So the has is just the sum of all the valence electrons the whole compound currently has. So each H has 1 electron, and each N has 5. So 5 plus 5 is 10, plus 2 is 12. And now what we want to do with these numbers, we subtract the has from the want, and in this case we get 8. Now this is the amount of shared electrons that are used in bonding in this compound. So if we want to find the amount of bonds, we just divide these amount of shared electrons by 2, and we get 4. So that means that this compound right here has 4 bonds. So we know that each H can only have 1 bond. So that means there must be 2 bonds in between the 2 ends. So we used up 8 of our electrons. And we have 12, so that means we have 4 electrons left to put in. And you might notice that both ends only have 6 electrons. So we need to add a lone pair to each of them. And this is our structure. Now for B, we do CH3OH. This one is a bit trickier, I think. So we start by drawing it out, placing the elements. So since we started doing organic chemistry, this shouldn't be too hard. CH3, this means that the carbon has 3 hydrogens bonded to it, and then there's an OH group also bonded to it. So now we count up the want. So it's 2 per hydrogen. So there's 4 hydrogens. So 2 times 4 is 8. Then it's 8 per other element. So there are two other elements. 2 times 8 is 16. So 8 plus 16 is 24. Then we subtract the has. So it's 1 per hydrogen. So that's 4. And then oxygen has 6. 4 plus 6 is 10. And then carbon has 4. So 4 plus 10 is 14. That gives us 10 shared electrons. Then we divide this number by 2 to find the amount of bonds. There are 5 bonds. And this makes it easy because there are 5 spaces in between the elements. 1, 2, 3, 4, and 5. So there are no double bonds in this compound. And since we used 10 electrons, we have 4 left because we had 14 electrons. And the oxygen only has 4 electrons currently, so we should add 2 more. And that's our final structure. Now we can do C. This one is a bit different since it's an ion with the minus symbol. So we can start by placing the elements. We have only one N, so that goes in the middle. And we can start by counting up the ones. So this is just 3 times 8 because there are 3 non-hydrogen elements. So that would be 24 minus the has, 6 per oxygen, and 5 for the nitrogen. That gives us 17. So that means there are 7 shared electrons, and we find the bonds. But wait, 7 divided by 2, that's 3.5. We can't have 3.5 bonds. So, might have noticed the mistake I made earlier. We don't actually have 17 electrons in this compound. Because of this minus here, we have 1 extra electron. So we actually have 18 electrons. Now if we do this again, we get 6 shared electrons. 6 divided by 2 is 3. And then, so we have 3 bonds. We only have 2 spaces, so that means one of them is going to be a double bond. And then we have, since we took away 6, we have 12 electrons left. So we just fill up these other element valence shells. So this oxygen needs 4 more, then this nitrogen needs 2 more, then this oxygen needs 6 more. So if you count these all up, 8 plus 1, 2, 3, 4, 5, 6, 14 plus 1, 2, 3, 4 plus 4 is 18, and that's what we have. So now we put the square brackets around it and put the negative charge because it's to show that it's an ion. And that's our final Lewis structure. Now for the last problem, we have SiO2. We have one Si, so that goes in the middle. When we're placing the elements, we should try to make it symmetrical. That's usually the best trick to doing it. And then we calculate the want, so it's 8 times 3, that's 24. Then the has, there's 2 oxygens and 6 per oxygen, so that's 12, and then 4 for the silicon, that's 16. So we get 8 shared electrons from this. 8 divided by 2 is 4 bonds. And there are only 2 spaces here, so that means there will have to be 2 bonds per space. And then from this, we see that silicon already has 8 electrons, but we still need to add 2 for each oxygen. So right now we used 1, 2, 3, 4, 5, 6, 7, 8. We used 16 electrons and we have 16, so that means we're done with this element. Okay, and that's it. Thank you to Jeffrey for requesting the video, and thank you to Matthew for showing me this other method.